In this video, we're going to discuss volume of distribution and how the properties of a drug can affect volume of distribution. So let us orient ourselves to the diagram. In the red, we have our blood volume, right? And in the average person, that's 5 liters. We also have plasma proteins, for example, albumin or alpha-1 acylglycoprotein. And we have our extravascular areas, right? Our muscle, our fat, our bone, etc. And here at the bottom, we've got 10 dots. And each of those dots represents a milligram of a drug. So imagine having 10 milligrams of a drug in your syringe and you're beginning to inject it into the bloodstream. And for this first example, this drug is highly lipophilic and it has some protein binding. So what's going to happen? Well, we begin to inject the drug, and because it's lipophilic, it doesn't like to stay in the vasculature very well. It's going to find fat, it's going to find other tissues in which it's more soluble in, right? Some of it will bind to these proteins, but most of it gets lost extravascular. And we see that we end up with 1 milligram in our blood volume of 5 liters. That's important because what is the formula for volume of distribution? Well, it's the dose that we started off with, that was 10 milligrams, over our final concentration of free drug. And we said that now is 1 milligram in 5 liters. So we have our final concentration. So let's do that math. We have 10 milligrams divided by 1 milligram in 5 liters. Now we can rewrite this portion and this whole function as 10 milligrams times 5 liters over 1 milligram. These cancel out, and our volume of distribution, therefore, is 50 liters. But think about that. Do you have 50 liters of blood volume? No. That's why it's called a theoretical concentration. In order to get the concentration that ends up free in the blood, we would have to place 10 milligrams of this drug into a 50-liter container. That's all that volume of distribution is telling you. Okay, so now let's go on to our second example. I'm sorry for that little glitch. So in this example, we got the same drug, or 10 milligrams of a drug, but this time the drug is not lipophilic at all, right? And in fact, it has no protein binding properties. This is a theoretical example, but bear with me. So we inject all 10 of these milligrams. None of it leaves. Every bit of it stays in the blood volume. Okay, so now what's our volume of distribution? Well, we started off with 10 milligrams, and now our volume of distribution is, our volume of distribution is that 10 milligrams divided by our concentration. And in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 milligrams in the average blood volume of 5 liters. We can rewrite that. And in this case, our volume of distribution is 5 liters. Now that's a lot different than our previous example in which our volume of distribution was 50 liters. And what was the difference with this drug? Is that it is not lipophilic. In fact, it's hydrophobic. It doesn't pass through membranes. And we said it had no protein binding capacity. So every bit of it stayed in the free form in the vasculature. In the final example, imagine this drug has moderate solubility, moderate lipophilicity, but it has high protein binding. So we inject the drug. we inject the drug, and immediately it sticks or it binds to every one of these proteins in the blood. Okay, and then we said it had a moderate solubility. Now what is left is 4 milligrams of free drug, right? 4 milligrams of free drug. Why? Because we've got 4 of the milligrams of the drug bound to protein. 2 of the milligrams went out of the vascular space due to its moderate solubility, leaving us with 1, 2, 3, 4 milligrams in our blood volume of 5 liters. Right? So our volume of distribution in this case is 10 milligrams divided by our concentration of 4 milligrams in 5 liters, and we know that we can rearrange this. It's also going to equal 10 milligrams times 5 liters divided by 4 milligrams. We do our cross multiplication. This ends up being 2.5 to 1, and we see that our new volume of distribution is 12.5 liters. I hope this video helped you clear up some things about volume of distribution. If you have any feedback, please let me know. Contact me through the YouTube channel or send me an email. I appreciate it. Thanks a lot.